Statics is the branch of mechanics that is concerned with the analysis of loads on physical systems in static equilibrium, that is, in a state where the relative positions of subsystems do not vary over time, or where components and structures are at a constant velocity. When in static equilibrium, the system is either at rest, or its center of mass moves at constant velocity. By Newton's first law, this situation implies that the net force and net torque on every part of the system is zero. From this constraint, such quantities as stress or pressure can be derived. The net forces equaling zero is known as the first condition for equilibrium, and the net torque equaling zero is known as the second condition for equilibrium. See statically determinate vectors. A scalar is a quantity, such as mass or temperature, which only has a magnitude. A vector has a magnitude and a direction and obeys the parallelogram law. There are several notations to identify a vector, including a bold-faced character V, an underlined character V, a character with an arrow over it. Vectors are added using the parallelogram law or the triangle law. Vectors contain components in orthogonal bases. Unit vectors I, j, and k are, by convention, along the x, y, and z axes, respectively. Force. Force is the action of one body on another. A force is either a push or a pull. A force tends to move a body in the direction of its action. The action of a force is characterized by its magnitude, by the direction of its action, and by its point of application. Thus, force is a vector quantity, because its effect depends on the direction as well as on the magnitude of the action. Forces are classified as either contact or body forces. A contact force is produced by direct physical contact. An example is the force exerted on a body by a supporting surface. A body force is generated by virtue of the position of a body within a force field such as a gravitational, electric, or magnetic field. An example of a body force is the weight of a body in the Earth's gravitational pull. Moment of a force. In addition to the tendency to move a body in the direction of its application, a force can also tend to rotate a body about an axis. The axis may be any line which neither intersects nor is parallel to the line of action of the force. This rotational tendency is known as the moment of the force. Moment is also referred to as torque. Moment about a point. The magnitude of the moment of a force at a point O is equal to the perpendicular distance from O to the line of action of F, multiplied by the magnitude of the force. M equals F asterisk D, where F equals the force applied, D equals the perpendicular distance from the axis to the line of action of the force. This perpendicular distance is called the moment arm. The direction of the moment is given by the right-hand rule, where counterclockwise is out of the page, and clockwise is into the page. The moment direction may be accounted for by using a stated sign convention, such as a plus sign for counterclockwise moments and a minus sign for clockwise moments, or vice versa. Moments can be added together as vectors. In vector format, the moment can be defined as the cross product between the radius vector, r, and the force vector. Varignon's theorem states that the moment of a force about any point is equal to the sum of the moments of the components of the force about the same point. Equilibrium equations. The static equilibrium of a particle is an important concept in statics. A particle is in equilibrium only if the resultant of all forces acting on the particle is equal to zero. In a rectangular coordinate system, the equilibrium equations can be represented by three scalar equations, where the sums of forces in all three directions are equal to zero. An engineering application of this concept is determining the tensions of up to 3 cables under load. For example, the forces exerted on each cable of a hoist lifting an object or of guy wires restraining a hot air balloon to the ground. Moment of inertia. In classical mechanics, moment of inertia, also called mass moment, rotational inertia, polar moment of inertia of mass, or the angular mass, is a measure of an object's resistance to changes to its rotation. It is the inertia of a rotating body with respect to its rotation. The moment of inertia plays much the same role in rotational dynamics as mass does in linear dynamics, describing the relationship between angular momentum and angular velocity, torque and angular acceleration, and several other quantities. The symbols I and J are usually used to refer to the moment of inertia or polar moment of inertia, while a simple scalar treatment of the moment of inertia suffices for many situations. A more advanced tensor treatment allows the analysis of such complicated systems as spinning tops and gyroscopic motion. The concept was introduced by Leonhard Euler in his 1765 book Theoria Motus Corporum Solidorum seu Rigidorum. He discussed the moment of inertia and many related concepts, such as the principal axis of inertia. Solids. Statics is used in the analysis of structures, for instance in architectural and structural engineering. Strength of materials is a related field of mechanics that relies heavily on the application of static equilibrium. A key concept is the center of gravity of a body at rest. It represents an imaginary point at which all the mass of a body resides. The position of the point relative to the foundations on which a body lies determines its stability in response to external forces. If the center of gravity exists outside the foundations, then the body is unstable because there is a torque acting. Any small disturbance will cause the body to fall or topple. If the center of gravity exists within the foundations, the body is stable since no net torque acts on the body. If the center of gravity coincides with the foundations, then the body is said to be metastable. Fluids. Hydrostatics, also known as fluid statics, is the study of fluids at rest. The characteristic of any fluid at rest is that the force exerted on any particle of the fluid is the same at all points at the same depth within the fluid. If the net force is greater than zero, the fluid will move in the direction of the resulting force. This concept was first formulated in a slightly extended form by French mathematician and philosopher Blaise Pascal in 1647 and became known as Pascal's law. It has many important applications in hydraulics. Archimedes, Abu Rayhan al-Biruni, al-Khazini and Galileo Galilei were also major figures in the development of hydrostatics.